All right, here's our bell word for the day. And this one's not, both of these aren't too bad. I am still going to use a table to graph these. But some of you may have the slope intercept stuff down and prefer to do it that way. Here, these are not in standard form, they're slope intercept form, so I can just choose values of x to put in. And it doesn't really matter what I choose. I'll go 1, 2, and then I'll even choose a couple negatives, see what happens. All right, so our equation, y equals 2 times x. But the first one, the first x that I've chosen is a 0. So that's 2 times 0, which gives me a corresponding y value of 0. 0, 0 is the ordered pair. We'll put it on the graph, but let's keep going. So next up, that'd be y equals 2 times 1, because it really is 2 times x. But I'm going to take the x and replace it with the x value we've chosen, which is 1. So x is 1, y is 2. You put in 1, you get out 2 out of the machine. Next up, we got y equals 2x, but now we've chosen an x value that is 2, which really just means it's 2 times 2, and that makes our y value 4. So we have the ordered pair 2, 4, and that looks good. Let's continue with our negatives. So it's y equals 2x, replace the x with negative 1, and then y equals negative 2. So we have the ordered pair negative 1, negative 2, and then we got a y equals 2x, but the x value now we're choosing is negative 2. That would give us y equals negative 4 as an ordered pair. So you'll see that this is enough ordered pairs to put on the graph, even though we could technically put more on. But let's put these on there. So I got the origin at 0, 0. I got 1, 2. Then we had 2, 4. That's all that we had there. We also had negative 1, negative 2, and negative 2, negative 4. So without doing the work, I'm going to put the rest of the points on there. Negative 3, negative 6, negative 4, negative 8, and negative 5, negative 10. But also 3, 6, 4, 8, and 5, 10. Okay, so that is my line for, I should have made it already, but it's my red equation, y equals 2x. Now that I have that, I'm ready to graph y equals 4x. So I'm going to use the table, x's and y's. Again, the same number of values should work, even though we could put more, I suppose. But let's find out. So x is 0. This equation is y equals 4x. But we've chosen to replace the x with 0. So I replace with 0, and I get a y value that is 0. Now again, some of you may notice what's happened there, but I'm going to continue as though we didn't notice anything, and I'm not going to put this on the graph yet until I get all my points together. So same equation, y equals 4x. Again, I'm just going to go up by ones, 1, 2, and then I'll even change the direction and make these negatives. Okay, so y equals 4x, but I replace the x with 1. That would give me y equals 4. So 1, 4. And then let's try an x value that's 2. Y equals 4x. Replace the x with 2 that we've chosen. Then y is 8. And yeah, it's actually as much as we could fit on the graph, I guess. So y equals 4x now for negative 1. X. Replace the x with negative 1. And then your y value is negative 4. So negative 1, negative 4. And then last of all, y equals 4x. But we're going to replace the x with negative 2. Then y equals negative 8. So we have the ordered pairs now that we can put on the graph. I'll start at the top of my table. I have 0, 0, which again, that's already on the graph in red. And that's good because that means we found the intersecting point. Then we had 0, 4, and then 2, 8. But also negative 1, negative 4, and negative 2, negative 8. And again, that's all we could have fit on the graph. So now that I have that, I am ready to draw the lines for my graph. That's decent. For my purple one and then my red one, I think I can do a little bit better than that. So yeah, something like this. Okay, I'll put arrows on the ends. Really just to make them look pretty. Now, is there a point of intersection? There is. Found it right here, and that would be the the solution at 0, 0. It's the only point that both equations are true with. So, did we see that in the ordered pairs? Yep, there was 0, 0. There was 0, 0. It was matching, and so we technically didn't need the graph, but it did say to solve by graphing. So there it is. We found the solution in the graph, but you could have found it with the tables as well. All right, here's our objective for the day. I can graph a system of equations with a calculator this time, which means that sometimes we may need to change a standard form equation into slope-intercept form. Take a minute, copy this down, then we'll get started. If you need more time, that's okay. You can just pause the video, really. But I'm going to get started with this lesson. Okay, when solving a system of equations by graphing, you're going to end up with two lines on the graph. And today we may even see some curved lines, and that's okay as well. So let's say, maybe we had something like this. And today we may see something that's curved. I don't know. That's not bad for me. But again, we would have this ordered pair, the intersection at whatever this ordered pair, the intersection is the solution. So as long as we can find out where that point is, then we're in really good shape, because just like we saw last time, it makes the red line true because it's actually on the line, but it makes the purple line true as well because it's on the line. And it doesn't matter if they're curved, it doesn't matter if they're straight, it doesn't matter. As long as they intersect somewhere, then we can find solutions to the graph. Now some of you may be noticing that if this was curved or if this straight line was sloped the other way, you could have two intersecting points. We don't care about that right now. We should only see one intersecting point on any of the questions for the assignment. You'll get to that, I don't think that's a 9th grade thing. I think that's a 10th grade thing. Now, for our purposes today, we are going to need to change the equations into slope-intercept form, which just really means that we're going to make ones and zeros. But it also means that we're going to solve the equations for y. So what that means is if you have a standard form equation, which is in the form ax plus by, and then that would equal c. Again, a, b, and c would be numbers, but you would isolate the y's first by zeroing out the x's, and then you would divide all the terms by the b, which we've seen before, and we'll see that in the next example. Okay, now for today's objective, which you hopefully wrote down, we are going to need these in slope-intercept form because all of these equations are going to be in the y equals format. That is why we are solving for y. Okay, so since we are solving for y, what I'm going to do is again, there's no distribution, no combining like terms, which we shouldn't expect, but I need to isolate the y. So I got to get rid of that 4x by subtracting 4x. Now you can kind of separate the minus 4x from the 16 on the right. Again, the objective here is to know that we're isolating the y's, and that, but on the right, 16 minus 4x, you can't combine those, which is why you need to keep them separated. It doesn't matter if you write the minus 4x underneath it, you still cannot combine it. So from left to right, 4x minus 4x is 0 as planned. That allows us to drop our two y's, which now equals. To make this in slope-intercept form, I like to put the x term first, but you don't have to, especially since we're just solving for y, really. And then I got my plus 16. Again, I did not combine these because they're not combinable. Last thing I'm going to do here is divide all the terms by 2. And what happens now is the coefficient of y, I'm going to make a phantom 1, which I've kind of shown there in purple. But instead of showing the 1, I'm just going to make it a y equals, and then I've got negative 4 divided by 2, which is negative 2. That's how many x's there are. And then the plus 16 divided by 2, which would be positive 8. Now, that is all I need for this problem. And again, you could have written that as y equals 8 minus 2x, and that would work, especially for the purposes we need for today, according to the objective. But this would be old-fashioned formal slope-intercept form, which may help you to graph. Because I think some of you may have been putting the y-intercept on the graph and then using the slope to find all the other points. So that brings us to a question like this one. Okay, you got to solve each system by graphing, and as fun as graphing is, and as tedious as making those tables are, it is better to have these in slope-intercept form. And I'm going to demonstrate why in a second, but let's take that equation. X plus 2y equals 12. Let's just solve that for y, all right? So again, I'd have to subtract x from both sides. You could say it's 1x if you'd like, because it is 1x. But I'm going to show minus 1x on both sides. So that does zero that out. I can drop my 2y's, which now equals, this time I'm not going to switch the order. I'm just going to make it 12 minus 1x, and that's okay. But to finish this off, the last thing I need to do is make the coefficient of y a 1, or really a phantom 1, by dividing all the terms by 2. So that makes my phantom 1 there. Y equals 12 divided by 2 is 6. And then I would have minus, you know what, we'll just make it 1x over 2, because it doesn't matter. Okay, now that would be the equation in kind of a slope-intercept form notation right there. Now, can we graph these? We can, but even doing these in slope-intercept form, I'm going to wait. And the reason I'm going to wait is because we can just put these onto a graphing calculator, which is the calculators that we have. The ones we use in our class is the TI-84 Plus. So TI-84 Plus is going to allow us to graph these. Again, slope-intercept form, you could say is b plus mx. Doesn't matter, just like we saw in that last example, which we're going to get back to. But to enter the equation into the calculator, you push y equals, which is in the top left of the calculator. You enter the equation, and then you push graph, and then it will show you the graph. Now, if you want to put in the second equation, once you put in the first one, you just go down. You just push the down button on the cursor, and then that will take you to a second equation, which then you can enter. And then if you wanted to do that, you would put that in, and then you'd push graph. Doesn't matter when you push graph. You can graph as many times as you want, but just, I guess, in terms of efficiency. Okay, so we're back on this problem. And you know what? Let's keep the process on here for putting the equations into the calculator, all right? So I'm going to follow this process, but before I push graph, I'm actually going to put both equations in. So here's my button progression on this, okay? So I'm going to push y equals. That's going to take me to the function screen on my calculator. If there's anything there, just delete it out. Just clear it out completely, okay? So I'm in y1, and I'm going to make it equal, up here, I'm going to make it equal x minus 3. Now to do that, I've got to push the x button first, which looks kind of like this. It says xt, kind of looks like a 0, but it's a theta, and then n. That's my x button. And then I got to push the minus button, not the negative button. This is the minus button on the right. I believe those are in gray on our calculators. Then I have the 3. Now, that would be good enough to graph that equation. But before I do, I would like to put the other equation into y2. So I'm going to push the down arrow, which is going to take me to y2. And now I can enter this equation. Again, I'm not putting in this one because there's no way for me to put in a y, but I can put in an x right there. So my button progression on this one, of course, we start with the 6. Then again, it's a minus button, not a negative button. Then it's 1x over 2. And you know what? At this point, I'm going to make it just x divided by 2. So I'm making that a phantom 1. But yeah, I got to push my x button again, x t theta n, which is my x button. And then it's a fraction. So I'm going to have to push the divide button, which is my divide by 2. Okay, so on your calculator, this is what you should see, right? This is what I'm seeing on my calculator. That's my 2 equations right there. I got my red one, I got my purple one. I'm ready to graph. So now I finally get to the point where I can push the glorious graph button. So I push graph, and what happens? You see the 2 lines go on to the graph, okay? So I do need to be able to graph these, and that's true. So you can use the table to graph them. Here's what we should end up with. And again, you can use slope-intercept form. My red equation there, x minus 3. That would give me all of these points, which I can then make a line with. So something like this. And again, the graphing calculator has already put this on to that graph. Again, it just doesn't have any grid lines on it. That's okay. And then our purple equation over here should show these ordered pairs that I put on the screen in purple, and that would give us this line. So something like this. And your graph looks pretty much like that, right? The screen isn't particularly proportional. That's okay. But at this point, I can see where my point of intersection is on my graph. Now, the way that I've graphed it, of course, we can see that the x value is 6, right? You just follow this line down to 6, and then you follow the line over to the y-axis, which is showing as positive 3. Now, since we're doing this by calculator, can the calculator tell us this information? And the answer is yes, because of this button progression right here. So we have our equations on the graph. The calculator's graphed them for us. If I wanted to find the point of intersection, this is my button progression right here. And you may notice what it's saying on the buttons. But if I push second first and then trace, you'll see right above it, because the second button for me is blue, right above it in where it says trace, it says also. So when you push trace, it's going to this function of the calculator which says calc. Okay, and sorry, that's kind of small there. But when you push second calc, it gives you a menu. It says calculate, 1 value, 2 is 0, 3 is minimum, 4 is maximum, 4 is intersect, 6 is dy dx, 7 is f of x dx. So after you push second trace, you should be seeing a menu like this one. What we want is the 5th operation there for our calculate in the calculator, which is why we push number 5. So you could just scroll down to number 5 and then push it, but if you push 5, it'll get you there quicker. So if I push 5, it takes me back to the calculator, and then at the bottom left it says first curve. So you push enter, and then you'd push enter again. That's the second curve. Now the next up, you'd move the cursor, just push left or right or up or down. Well, just left or right actually. So you get really close to the intersection, and then you push enter again. Now, as I've pushed this sequence on my calculator, again, I got really close to my point of intersection, but I pushed enter here. I did enter, enter. I got really close to this intersection. I pushed enter again. And at the bottom of the screen, it is now saying, it says intersection x equals 6, y equals 3. And as it turns out, remember up here, that's the same exact ordered pair that we got when we graphed the two lines. Now I kind of used slope-intercept form. I didn't go over it. You can use the same method we did in the last lesson as well. Either way, you need to get this same ordered pair. The graph would have given us those values right there, okay? And in fact, remember on the bell work how we made a table? The calculator will make a table for you. All you got to do is you got to access the table function, and to do that, all you got to do is push these two buttons, and then it would give you the table of values. Now, it's not always going to work that way, and that's all right too. But here's what you push. You push second. Then this is just to get a table. You would push second, and then you would push graph. That's it. So if you push second graph, then you see it's giving you values of both y1 and y2. Those are ordered pairs. So it'd be like -2, -5, -1, -4, and you could go down for x and y1s. But then you also have x and y2s. Those are ordered pairs. They're just separated by that by the y1 values. Now, with the values that I have, if I scroll down until my x is showing as 6, you'll see that it shows 6, 3, 3. That tells us that the two y values are the same when the x is 6, because it's two ordered pairs of 6, 3, one for the purple line, one for the red line. So again, we have found the ordered pair. That is the solution. We've also figured out a way to graph without actually having to make the table ourselves. Remember, the calculator will make that table for us. In fact, I'll demonstrate that on the next problem, even though it may not give us the exact solution. Okay, so this takes us back to, we got an exponential equation right there, and that's okay. Looks like that's kind of unit 4 kind of stuff for us, which was a long time ago, but still, we can do it. In fact, I'm not going to do it. The calculator is going to do it. So first off, I'm going to show my red equation, and like I said before, I would like to put some points on the graph. We'll still get into solving the intersection with the calculator, but first let's see if the calculator will give us a table. So I don't have to calculate anything here. But this is my button progression for my red equation. So first off, I got to get to my graph, or my y equals. So in the top left, you push the y equals button. Now we're going to enter the equation. You got 3. That's my base. I got to push my exponent button, and then I've got to push the x button. Okay, now it says x, t, theta, and n. So you may have to find that. It's one button to the right of the alpha button. Now, after that, I've got to get out of exponent mode. So I've got to push over, and then I will push 8. That is my full equation right there, okay? So what I'm going to do is I'm actually going to just go down so I can enter in the second equation as well, okay? So I'm going to go down, and then I enter my second equation. So this is under y2 now for me. But I've got to do negative x plus 3. So first I will start with the negative button, which is right next to the enter button. Okay, now it's got the parentheses around the minus sign, so it's not the minus button. It's one button to the right of the decimal. And then I've got, it's negative x, and yeah, that's plus 3. So I got to push the plus sign, and then I push 3. So I'm ready for the table now. So to access the table function, I'm just going to go directly and say second, and then graph. And this will take me to the table. All right, so here's what I'm seeing on my calculator right now. Okay, now I'm putting this out so that you can understand how it works with both on the same screen at the same time. I've got x, y1. y1 is the y values of our first function in red. y2 is purple because it's representing the second function in purple. And here's the values that it shows me. I'm going to put them all down. All right, so this is what I'm seeing. I'm going to start with the red equation. I'm going to put it on the graph as best I can. All right. So I see I got 0, negative 7. That's that point. I got 1, negative 5 here. And I've got 2, 1 there. And 319 is already way off the graph. In fact, the further I go to the left, I have kind of an asymptote right here at negative 8. So I'm expecting this graph to get really flat at negative 8 going to the left, and then it gets really steep as I go through here. So, sorry, through here. I don't think that's a better line, but, you know, something like this, okay? Now, it gets a little wavy in there because the technology thing, but that's okay. And that came from these ordered pairs. I was only able to fit these here. I got 0, negative 7, that's here. 1, negative 5 is here, and then 2, 1 is here. So just understanding it goes up here and then flat as we go close to negative 8, which is our asymptote. But now I'm ready to put these purple ordered pairs on the graph, and they're not showing these on the screen, of course, but I'm going to put them down anyways, because the 3 there would have been the ordered pair 0, 3, because it corresponds with an x that's 0. So there's 0, 3, which we could put on the graph, and I guess I can do that right now. 0, positive 3 there. But then we have these other ordered pairs as well for all these other values. Okay, so again, the calculator is not showing this part, but it is essentially with the table here. So it's showing a little bit different, but it's the best the technology can do with the technology that we have. So I'm ready to put these points on the graph. We got 0, 3 already on the graph. We also have 1, 2. We have 2, 1, which is already on the graph in red. 3, 0. 4, negative 1. 5, negative 2, and 6, negative 3. Of course, this pattern would continue for both directions, so you could, if you wanted to, just put these points in, even though the table did not give us these ordered pairs, but you can put them in, and then we can draw the line on the graph. So that's how you would do this by hand if you were using the calculator to make your table, and it's perfectly legitimate to make the calculator do the work there because that's what it's there for. Okay, now, I haven't seen the graph yet on my calculator, but if I push graph, all I've got to do is just push graph. I don't push second first, because that's how I access the table. But it starts by drawing this line here, and then it shoots up here. And then, once it stops, it starts my purple line going down this way, and then it shows this graph. Now, what I would like is the point of intersection, right? So here's my button progression. Remember, the 5 is going to access the intersection function of the calculator. So I push second, trace. So I'm in the calculate menu. I push 5, which will take me immediately to the intersection function. And then I push enter, enter. And now the cursor is right here for me. So I'm just gonna move it over a little bit closer to the intersection. I just gotta be close. It says guess, and I push enter. So I'm here now, I push enter. And what does my calculator say at the bottom? Well, my screen is showing something like this. It says intersection x equals 2, y equals 1. Now, did we really need the graph for this? Well, we do for the assignment, but it was already showing on the table right here because, again, this would have been 2, 1 here in red. That would have been the ordered pair 2, 1. And then we already saw the purple ordered pair would have been 2, 1 as well. So once we saw that these values match, that's where it intersects. And you could have used the table in order to figure this out, but again, you still may have to draw the graph on the assignment. But that's one way to do it. Again, or I guess we did it twice, really. But this is how I'm going to be doing the rest of these problems today. Now, are you okay doing this by hand instead of using the calculator? Of course you are. We'll never force you to use one specific method, but just be careful because I think some of the rest of these problems are going to have fractional values, in which case we may have to do some rounding. Okay, this one, again, I'm expecting some kind of weird value right here, but I'm also expecting to put the equations into the calculator. So this would be my red one. This would be my purple one there. Red is 2 to the power of x minus 5. And my purple one, negative x plus 4. So I'm just going to enter this into the calculator. It's nice that it's already set up for me. And again, the setup on the calculator will be something like this. So I'm going to have my y1 values in red. It's going to give me the ordered pairs from the red equation. And then my y2s is going to come from the purple equation. Then it's just going to give me a bunch of values, and let's see what happens there. So I'm going to go to the graphing function of the calculator. So that's just the y equals button in the top left. And I have some equations there, so I'm going to clear them out first. But I'm going to go back to y1, and I'm going to enter that first equation that we have, which is 2 to the power of x minus 5. So I push 2. Then I have my exponent button, which looks like this. It's one button above the divide button, and then I push x. Okay, now it's xt theta n. It's one button to the right of alpha. Now I've got to get out of the exponent mode, so I push over. And then I would push minus, not the negative button, but minus 5. Now that puts that entire equation into my calculator right there. So at this point then, I'm going to go down so I can put in my y2 function, my second function. So I go down, and now I'm ready to type in my purple equation, negative x plus 4. So I've got my negative button, which is in parentheses there. It's one button to the right of the decimal button, negative x, and then we got plus 4. So plus, and then the 4. So that's going to put into my calculator the second function, which is what we do want. I mistyped something there, so let's try that again. Negative x plus 4, so that's in there. Now, the first thing I want on this is the table. So at this point then, now that I have my functions in there, I want the table. I'm going to push second, and then I'm going to push graph because that is where the table is. Okay, so second graph gives me this table. So I'm going to put the values in there. All right, there's my ordered pairs. We got 0, negative 4. We got 0, 4, 1, negative 3, 1, 3. Now you should look at these values and be able to find a value that matches in your y's. That would indicate some kind of intersection. The problem is that no matter how far up or down you scroll, at least with the values that we have, you never will find a value that matches in our y1 and y2 columns, which indicates that the table is not going to tell us where the intersection is. So we can still use these points, though, to put the 2 lines on the graph. So I'm going to start with my, I'll start with the red equation. So that's 2 to the power of x minus 5. There's 0, negative 4 right here. We got 1, negative 3 here. 2, -1, there. 3, 3 is good. And in fact, 411, while I can't actually fit it on the graph, I can still fit it on my screen, you know, about right here. That just gives me a nice indicator of where this is. This is telling me I got an asymptote at -5, so I can't pass the -5. So we should get something that looks a little bit like this. Going to the left, right, it's getting really flat at -5, and then it just shoots up here, going to the right. Okay, so again, it's not my best line, but it's not my worst line doing it on an iPad. We couldn't fit 527 or 659 on there, but it's going up really, really fast. Now, since this is my Y1, when I put it in the calculator and I graphed it, it put this line first, going from left to right, it goes left, and then it just shoots up again. Okay, now I'm going to do the purple one by hand as well. The 4 there comes from 0, 4, so that would have been 0, 4. So I can put that on the graph. We also have the other ordered pairs. Again, they're paired with these X values on the left. Okay, so again, I'm just kind of pointing out where these ordered pairs come from, and it comes from these rows in the table. But it gives me these ordered pairs that I can put on the graph. We have 1, 3, 2, 2, 3, 1, 4, 0, 5, -1, and 6, -2. That's all the points we have. Of course, we see the pattern, and we can put in the rest of the points in both directions as well. So there's our points. And now we'll use some technology to graph this one. It's not too bad. Okay, there it is. Now what we see here is right in the middle of that box, or close to the middle of that box, is the intersecting point. Problem is that it's fractional value, so we can't just say, you know what, that's 3,2 or 2,1. We can't say that because those values are not very well defined. So what I'm going to do is I'm going to go to the calculator and let's see what happens. Okay, so I'm going to punch in the button progression in order to find those values, and then at the bottom of my graph, it should say something like intersection, right? Which we've seen already. Okay, and then it'll say X equals and then Y equals. So here's my button progression. Okay, so I put it down here. We've seen this already. Okay, so I'm ready for my intersection. I push second, trace, 5, enter, enter. Now, actually, mine is showing almost right next to that intersection, so I'm just going to push enter. I don't actually have to scroll over like I usually do. Mine was already showing about right there. And here's the values that it gives me. Okay, so it's showing me these two values right here. Remember what it said up here? It said you got to round to the nearest hundredth, so that's what I'm going to do. And round both place values. I'm going to start with the X. Okay, so my X in the hundredths place value is a 6. The 3 is going to keep the 6 as 6. So that would make my X value 2.66. And then the Y, we got a 3 there, but the 6 is going to add 1 to the 3, making that 1.34. So that's kind of small there. Let me emphasize my ordered pair here on the right. Okay, so I got an X value rounded to 2.66 and a Y value that's rounded to 1.34. And that would be my solution. It's only estimated because we can only estimate these values since we're eyeballing it, but the calculator is doing all that work for us. And that's what's nice about the calculator. These decimal values are why you won't see these matching values in the table, because you see the X value is only going up by 1, 2.66, somewhere in between here, right? But it's not going to show you that decimal value because it's not programmed to do so. So we're going to solve this system by graphing. We're going to make 2 tables. Well, it's a table. It's one table in the calculator, right? So again, it should look something like this. You got the X, and then it's going to give us 2 Y values. You got Y1, and then you also have Y2. Okay, so I go to my calculator, and I say, you know what, I'm going to punch this in. So let's do that. So I've got to go to my Y equals button. That's the first button I gotta push. Now that's in the top left of the calculator. Y equals, now since we just did a problem, we're gonna have to clear out those functions, okay? So if you gotta push clear, then do it. But for this one, since my 1/3 is in parentheses, I'm gonna use parentheses on this one. So open parentheses, that's one button above 8. So I'm gonna open a set of parentheses. Then I'm going to do 1/3. Okay, so 1 is fine, but the fraction line is the divide button. Okay, now I got my denominator of 3, and then I'm going to close that set of parentheses, which is 1 button above 9. So on my calculator right now, it is showing y1 equals 1 parentheses 1/3 close parentheses. So I've got to access the exponent button. So I say exponent, and then I've got to push my X button, okay? So now in the calculator it shows a little exponent right there with my Y, which is exactly what I want. Okay, so that's the first function that we have. We did this one in red right here. Now we're going to do this next one in purple. But what's the problem that we see? It is not in slope-intercept form. It's not in y equals format, which is what we need on this. So we're going to have to use principles of equality to change this into y equals format, right? So we're going to solve for y. So I'm going to use principles of equality. Let's get rid of that 2x. So if I subtract the 2x on the left, I'd have to subtract 2x on the right as well. So minus 2x there. So that does zero that out. I can drop my 5y's, which equals, again, we don't have to change the order for this because it's not, we really don't care that it's slope-intercept form. We just want y equals format. The 5, I don't want the 5 there either with the y, so I'm going to divide all the terms by 5. So that makes y equals negative 30 divided by 5 would be negative 6. And negative 2 divided by 5 would be negative 2/5. Now I'm going to put the x on the right. If you'd like to, you can keep that x with the 2 if you want. It's not going to matter. But since I'm a math nerd, I'm going to keep the x. Oh, once it lets me. I'm going to keep the x here on the right. Okay, so now I'm ready to put this in the calculator because I now have the format y equals negative 6. It's just y equals stuff, okay? So I go down, so I gotta tell the calculator, you know, we're gonna go down to the second function, right? That's gonna be our y2 function. And we're gonna type in negative 6. So I need the negative button, not the minus button, negative 6. And then minus, so that actually is the minus button. Now 2/5 x, so this would be 2/5. So I'm gonna type in a 2/5. So that's a divide button, 2/5, and then I can just push my X button, okay? Now, why does this work? Even though on the calculator, it's gonna show up like this. So it's gonna say, well, you got negative 6 minus 2/5x, like this. Why does that work? It's because of the order of operations, which I really don't wanna go into right now, so I'm not going to, okay? But now that I have this function, the second function, the purple one, in the calculator, I'm ready to for the table, okay? So the table, I want to see x values. We should give us x 0, 1, 2, 3, 4, 5, at least 6. Okay, so to access the table, again, you're going to push the second button in the top leftish, and then you're going to push the graph button, which is that's how we access the table there. So second graph, that gives us the values in the table. So I'm going to put these down. All right, so those are the values that I got from the calculator. Okay, so I'm now ready to put these onto the graph. So I'm going to start with the red ordered pairs. So I got 0, 1. Okay, that's my y-intercept right there. I have 1 and 0.333, you know, something like this, and then we're getting really close to 0, right? Because this is a curved graph, we should end up with something like this. Now, yeah, I'm doing it by hand, so it kind of sucks. So what I can do is I can actually go up on my table, and then I can see other ordered pairs. For example, it also showed me negative 1, negative 1, 9. Oh, sorry, negative 1, 3. Negative 1, 3 right here. And then it also shows me negative 2, 9, which is way up here. The rest of them are off the graph. So I have these ordered pairs, which again, I got these ordered pairs from the calculator, right? From the table. Okay, so I know that this graph is just gonna go up pretty quick, something like this. All right, well, what about the purple one? Well, we have the ordered pairs, the ones that I can fit on the graph. I got 0, negative 6, So 0, -6 would be down here. Then we had 5, -8 down here. So if you scroll up or down, you should get these other values, it looks like. So down 2 to the right, 5. This one right here at 10, -10. And then looks like -5, -4. And then also -10, -2 right here. So I get this graph right here. Okay, well, where's the intersection? Well, it's not showing on the graph, but it could happen somewhere else. So let's try this. Let's go back to the calculator. Okay, so I'm going to push second trace. So second trace, which is one button to the left of the graph. I push 5. Okay, now it's going to graph the lines for me, and it looks pretty much like I have it on my graph, both the red and purple lines. Once it's done graphing, I push enter, enter. I don't see an intersection, so I'm just going to push enter, and let's see what the calculator says. Oh, okay, so at the top of the calculator, this is what it shows. Okay, so it says error, no sign change, and then 1 quit. That's all. That's the only option it gives. It says, you want to quit? Well, you're only giving me the option to quit, okay? So what this also means, since there's an error, no sign change means that this one, it just simply has no solutions. Okay, meaning those two lines that we're looking at, they will never intersect. So one none and infinite solutions. We just saw an example that had no solutions. Okay, so the lines never intersect. We know now what that looks like on the calculator. We've also seen several that had one solution. That just means the lines intersect once. It's possible that they could intersect twice, but we're not going to go over that today. Probably not in 9th grade either. But you could have infinite solutions. So if by chance, here the second part, infinite solutions. Let's say you got this graph, and what happens is it graphs the first line, and then what it's going to do, it's going to graph the second line right on top of it, so you won't see a second line. That means that you have infinite solutions because, again, where does these two lines intersect? They intersect everywhere. So we would say infinite solutions on this one. Just be aware, you're probably going to see this type on the assignment. So when you put it on the graph, you may only see one line. It's just graphing the same line twice at the same place. Here's our two objectives. And then I can graph a system of equations with a calculator. And I can change standard form equations into slope-intercept form. And again, the reason why the second one is important is so that we can put this stuff into the calculators.